All right, we're working on 6.7 equivalent expressions, and that starts on page 495. The first thing we're going to work on is our vocabulary startup. It says when addition or subtraction signs separate an algebraic expression into parts, each part is called a term. So like for instance, we'd have this example, there's 3 terms here. The numerical factor of a term is that contains a variable is called a coefficient. So let me just write a little thing over here for coefficient. If we have something like 3x, this is our coefficient, and this is the variable. Okay? So the term without a variable is called a constant. So if we're talking about just the number 7, that's a constant. Okay, that's an example of a constant. It's a term without a variable. It's a constant. Like terms are terms that contain the same variables, such as x, 2x, 3x. So let me just give you some little examples over here so that you can think about what like terms are. So I'm going to give you some examples. And so what I'm going to do is I'm going to use a circle for my constants, which are my 5 and my 2. Those are like terms. If this were a problem that was like an addition problem, and it was y plus 5 plus 3x plus 2 plus 4y plus 9x plus x, I know that I can combine 5 and 2 because they're like terms. I can add 5 and 2 together. So then let's do a square around my x variables. Okay, I've got my 3x here, I've got my 9x here, and I have my x here. So combining like terms. Remember that in front of this x here, there's that invisible 1. So don't forget there's like our little invisible 1 in front of it, a variable that doesn't have a coefficient. All right, now I'm going to, let's make a heart around our y values. Oh, look at that. Oh, that's a horrible heart. Oh, nope, that one's horrible too. Here with my little invisible 1 in front of it. And so I want you just to see that these are different terms, okay, different variables. We have constants, we have variables y, we have variable x, and we can't combine unless they're the same term, the same variable. All right, so back to this little picture here. So we've got our 3 terms because they're all separated by an addition sign. Because remember that terms are separated by addition and subtraction signs. Because automatically multiplication signs mean coefficients, right? 3 times x, that means 3 is the coefficient for x. So let's see, labeling the graphic organizer below. So here we have our 3 terms, okay, 3 terms. The n values, these are our like terms. And then the 9 is called our constant. And if we were talking about, if they were just underlining maybe the 2 and the, the 2 and the 4, we could call those our coefficients. Okay, so I just wanted to put that out there. So now let's move on. It says, real world link, Andrew's mother gave him a computer game and $10 for his birthday. His aunt gave him 2 computer games and $5. The expression x plus 10 plus 2x plus 5, where x represents the cost of each game, can be used to represent Andrew's birthday gifts. So we've got, this is the computer game that Mom gave him. And here's the $10 that Mom gave him. Then here's 2 of the computer games that Aunt gave him and the $5 that Aunt gave him. Now, if I were putting these together, what is the coefficient in the term of 2x? The coefficient is the number 2. How many terms are in the expression x plus 10 plus 2x plus 5? Remember that terms are separated by addition or subtraction signs. So if you see we've got x plus 10 plus 2x plus 5, How many terms do we have there? That would be 4 terms. Now, it doesn't ask you to do this, but why not just jump in? We've got x's and we've got constants. So we're going to combine our like terms. So I'm going to draw my sticks and my dots, okay? So here's my 1x. Here's my 10 dots. Then here's my 2x's. And here's my 5 dots. So if I'm combining like terms, I'm going to put together my 1, 2, 3 x's and my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 ones values. And since I know that X represents the games, I've got 3 games plus $15 cash. All right, so simplifying expressions that have one variable. To simplify an algebraic expression, use properties to write the equivalent expression that has no like terms and no parentheses. So I like that they have 3 plus 3 here, and then they call it 2 times 3, because that's just repeated addition, right? With the variables here, x plus x, that means we have 2 x's. So 2 times x, right? Just like over here I have 2 times 3, because there's 2 3's, I have 2 times x, because there's 2 x's. But the other way I like to think of this is as I have 1x here plus 1x here, so altogether I have 2 x's. If I were using my sticks, 1x plus 1x, I have 2 x's. Alright, so example number 1, it says simplify the expression 4 times 6 times x. And I like to say it just like I did, 4 times 6 times x, because that's what it is. There's no multiplication sign between the 6 and the x, but we know that that is multiplication. So if we were to rewrite this, I would write it as 4 times 6 times x, written all the way out, and then I know that I can put together, because of associative property, instead of keeping my 6 times x together, I can do my 4 times 6 together, because it's all multiplication. And I know how to do 4 times 6. That's going to be 24. And so it's still 24 times x, because that x just doesn't disappear. It's still there. Notice that this says simplify. I'm not solving it. I can't solve it because I don't know what x is, but I can simplify it from 4 times 6x to 24x. All right, so I want you to try that with A, B, and C. If you'd like to use for B and C the sticks and dots method, go for it. Remember using commutative and associative properties for A. Go ahead and try it on your own, and then we'll come back and I'll show you my answers. All right, and here are your answers. For A, I changed the order and I made it 3 times 11 then times x. And so I can do 3 times 11 is 33. And don't forget to leave the x in there, so it's 33x. For B, I have x plus x plus x. So I know that's 1x plus 1x plus 1x. And if I'm using the sticks, 1, 2, 3, and if I look at it, that's 3 x's. For C, again, I could use the sticks, but I just knew that I've got 7 x's and then 1 x over here. And if I'm combining that, then that's going to be 8 x's altogether. I can't combine my 8 in the middle because that is the ones, that's not x's. So again, if I were to use my sticks, 1, 2, 3, 4, 5, 6, 7, and then my dots, 1, 2, 3, 4, 5, 6, 7, 8, and then another x over here, I have 8 x's altogether plus 8 ones. So 8x plus 8. So number 2 says 3 friends will pay X dollars each for admission to the museum plus $1 each to view the mummy exhibit. A 4th friend will pay admission but will not view the mummy exhibit. Write and simplify an expression that represents the total cost. All right, so it's X dollars to get in to the museum. We've got 3 friends, 3 people are going to pay X plus $1. They're going to pay X dollars to get in the museum plus $1 more for the mummy exhibit. And then we also have one more friend that's coming, but they're just going to the mummy exhibit. And I'm sorry, they're only going to the museum. They're not going to the mummy exhibit. So that's just plus X, not plus X plus 1, just plus X. So if I were to work this out, I know that there's going to be 3 admissions plus $3 for the mummy plus 1 more admission to the museum. So altogether, I've got 4 museum admissions plus $3 for my mummy exhibit. And I got that from taking my 3X and my 1X and combining them to make 4X's. And then plus my 3 more 1s. Alright, now you're going to do this on your own. It says write and simplify an expression for the total cost of 6 friends to go to the museum if only 4 friends view the mummy exhibit. Remember that it's an extra $1 to go to the mummy exhibit and it's X dollars to go to the museum. Alright, so I'm going to have you set that up. Now we might write our initial expression differently, but when we simplify it, we should all have the same answer. So go ahead and work on that, and when you come back, I will have the answer for you. Pause the video. Alright, I think the simplest way to do this is to say, to separate it out. 6 people are buying the museum tickets, so 6 times X for the museum tickets, plus 4 of them are going to view the mummy exhibit, which is $1, so 4 times $1, and so we end up with 6X plus 4. Now you may have decided to do 4 times X plus 1 plus the extra 2 people that are only paying for the museum. Ultimately, you're still going to come out to 6X plus 4. So this could be a little bit different depending on what you were going with, but this is going to be our final answer when we simplify. And no matter what, you'll get that answer. Alright, so simplify expressions with 2 variables. Properties can be used to simplify or to factor expressions with 2 variables. Compare the effects of operations on numbers to the effect of the operations on variables. So over here we have 3 plus 3 plus 4. And so they're saying that you can combine your 3's and say, oh, okay, that's 2 times 3 plus 4. And over here we've got x plus y. And so they're saying, oh, we've got 2 x's and 1 y. One, it says 14y plus x plus 22y. Now, honestly, there's no reason to have anything in parentheses right now. You would need to change the order if you want to combine your y's this way, and then put your y's together so that you have 14 plus 22 y's. For number 4, it says simplify 4 times, and in parentheses, 2x plus y using distributive property. And don't forget, distributive property is our beautiful rainbow. And I know you all are very impressed by this rainbow I'm about to do for you, so I'm going to go ahead and impress you. So we've got 4 times 2 times x plus 4 times y. And so I can do 4 times 2. That's 8. And don't forget, it's 8 times x. So I'm left with 8 times x plus 4y. That's called simplifying. All right, now for number 5, it's saying factor 27x plus 18y. Greatest common factor is what we're looking for. The variables are not even involved here because I'm not going to have a greatest common factor that includes x's, and I'm not going to have a greatest common factor that includes the y's. So they're just going to end up staying where they're at, okay? But I can find my greatest common factor between 18 and 27, okay? And we'll go ahead and put these extra little things here. So I know it's 1 and 18. 18 doesn't go to 27, so is not a factor of 27, so I'm going to move on. 2 times 9. 9 is a factor of 27, and so that's the biggest one that we're going to work with. So I know that 9 is going to be on the outside of my parentheses. So now I'm going to do 27 times x divided by 9. That's going to be 3 times x because the x doesn't go away. Plus 18y divided by 9 is going to be 2y. And so there's what I'm left with. 9 times, and in parentheses, 3x plus 2y. All right, so you're going to do E, F, and G on your own. E and F are for simplifying, and then G, so combine like terms, and then G is going to be factoring. When you come back, I'll show you the answers. Pause the video now. All right, and here are my answers for E, F, and G. I combined my like terms in E, so I put my 3x's and my 2x's together to make 5x's plus 9y's, because there's nothing I can combine with my 9y's, so I just leave them alone. For F, I did distributive property, and so I did 7 times 3 times x plus 7 times y, and so I have 21x plus 7y. And then when I was factoring out, I found that 4 was my best number to factor out of 12 and 8. So I did 4 on the outside of my parentheses, and then I divided by 4. The 12x divided by 4 was 3x, and then the 8y divided by 4 was 2y. And so that's how I got my answer. Example number 6. Let's get this back in here. It says the farmer's market sells fruit baskets. Each basket has 3 apples in one pear. Use A to represent the cost of each apple and P to represent the cost of each pear. Write and simplify the expression that represents the total cost of 5 baskets. So we know that we're going to have 5 baskets, and in each basket we're going to have 3 apples and 1 pear. And if we want to know the price, it's going to be 3 times A plus 1 times P, which is just P. But we're going to get 5 groups of that. And so using distributive property, I'm going to do 5 times 3 times A, which is 15A, plus 5 times P, which is 5P. So in the end, I'm left with 15 times A plus 5 times P. And that's the cost of 5 baskets. Now, obviously, we don't know what the actual cost is. That's just writing and simplifying the expression. That's the best we can do. All right, so that is the end of 6.7 equivalent expressions. If you have any questions, ask me in school.